All right, we were talking earlier about igneous rocks. I just wanted to show some examples. The most important are, of course, basalt and granite. Okay, so he's showing here and here. Obsidian is a type of glass, a black glass that you find near volcanoes. Um, you know, these others are a little bit more exotic, but basalt. There's a nice picture of basalt. There's a nice picture of some granite. And just to let you know, as far as igneous rock goes, this pumice is actually less dense than liquid water. So this is the only igneous rock that will actually float in liquid water. So I just thought I'd point those out. Let's see some other stuff that we just mentioned. So this is, of course, this is a shield volcano. This is the cinder volcano right here, and this is the composite volcano. Let me just say a couple more things about them. These shield volcanoes, the reason that they're so wide, and the biggest volcano in the world, in fact, I'm sorry, the biggest volcano in the world, which is Mauna Loa in Hawaii. I'll show you that in just a moment. The reason that these things are become so big, and the reason that we have shield volcanoes is that it has to do with the lava, the way the lava comes out. Okay, so if the lava easily comes out and forms over a large amount of this huge amount of time, hundreds of thousands to millions and millions of years, you'll get this very, very wide, and the slope of the shield volcano is very, very low. For a one of these cinder volcanoes, the slope is very high, and it usually has this little divot, if you will, in the sometimes it's called a caldera, in the top. And these are very very explosive volcanoes because the lava it has a difficult time getting through. Also, the composite volcanoes are like that too. So with the composite volcano, you have this wide base and relatively small slope, a low slope, and then the slope becomes larger and larger as you get towards the peak. All right, so that would be an example of a composite. The cinder they just jut up at a very great angle, and then of course the shield volcano very, very gradual. All right, so here let's take a look at the next page. This is from your textbook. I like this picture right here because what this is showing you. So just compare some of these other volcanoes to Mauna Loa, right? The biggest volcano in the world. And even if you looked at it under the ocean, it's by far the biggest. I know that obviously Mount Everest is the highest, but as far as like the shield volcanoes go, this thing is gigantic. I mean, look at it, nice a gradual rise and this huge base. All right, so let's move on. All right, so I was just trying to do a little bit of review about shield volcanoes. We were just talking about in the last video. I had ended with sedimentary rock, and so this is this process of weathering. So this is a good example. This picture right here is showing you some mechanical weathering. There's actually a nice picture. So look right here. So this is a good example where water gets into these cracks. These tiny little cracks that are already there, let's say, in the rock, and then freezes, and the freezing expands, and then the rock breaks up. All right, so that's this idea of weathering. All right, let's go back to these. All right, so let's see. Let's see. So the difference between like weathering and erosion is when the material that comes off, and by the way, erosion is and weathering as well. It's dominated by water, right? But anyhow, erosion is when the material that comes off of these rocks moves, so it's undergoing motion. That's important. Deposition is when the material stops moving, and by the way, as it moves, let's say it's like a little pebble or something like that, and the pebble might have started off relatively sharp, and so what happens is even though it started off relatively sharp, move this over a little bit, it might have started off sharp, but as the deposition is taking place, as it's moving, then it becomes more rounded. All right. And then ultimately it's deposited. Sometimes the deposits are very orderly. You'll have all of the same grains. We'll see that in just a second. And then sometimes the deposition is not orderly, where you're going to have large grains and small grains. All right. And that's something you can just look at and you can see. And then, of course, the sedimentation that occurs one layer at a time, where stuff gets buried and ultimately glued, if you will, together. Not with glue, but with dirt and sticks and fossils and all sorts of stuff. All right, so let's get more into this. All right, so the mechanical weathering, we just mentioned that. The chemical weathering, which is primarily through water, and of course there's different chemicals in the water. That's the primary thing is that goes on, is the chemical weathering. All right. So this is just that's that same picture I just showed you. All right, so just keep in mind this idea of thermal expansion. When it gets so something gets cold, it expands. It expands, and then when it gets hot, sorry, the opposite. What did I just say? When it gets hot, it expands. When it gets cold, it contracts. All right, so that's let's see. So biological activity, yes. You can have plants and animals that go into this, go into the sedimentation. All right, so we let's say the rocks are breaking down, and their internal structures of the minerals are breaking down. Of course, water is the thing. Like, this is a good example, right? This is just some boulder that's probably been sitting there for millions of years, and then over time, you can see these cracks will get bigger and bigger, and then larger chunks of it will fall and make smaller chunks. And then as the water, let's say there's a flash flood, or who knows? There's all sorts of things that can take place over the course of millions of years, and the material that made up this boulder gets spread out, basically. So erosion is the physical removal of material by mobile agents such as water, wind, ice. Of course, like you think of the ice ages, right, where the glaciers were on the move. We'll focus much more on that, in future chapters. All right, and of course, gravity is going to pull these boulders. If the the rock here. Let's take a look at this picture. So over time, if let's say this rock underneath this smaller rock, if this erodes and just becomes mechanically, it can't hold this rock above it. This rock above it will it'll break and fall down, right? Just because of gravitation. Oops, I skipped forward too far. All right, so all right, erosion doesn't take place it doesn't occur in place. There's movement that's involved. All right, so keep that in mind. If you think erosion, you're thinking that it involves some kind of movement, with water, wind, ice, or gravity. All right, so deposition. This is a good example where you have very sorted deposition. Notice all these grains. So that here's just this key is here for scale size. Just to give you an idea of the size of the grains. Notice this one right here. This one is not sorted very well because you have relatively large pebbles and then much tinier ones, right? And so that there's just kind of a mixture of all of them. All right. So the one thing is when you're thinking about deposition is the larger particles will stop first, right? Because it's harder to move them, right? It takes more force to move them, and then the smaller particles will keep moving, and will stop at until there's nothing else to push them. Like as the water let's say it's a flood, and the flood water gets lower and lower and lower, then the smaller particles will be the last things to be deposited. All right. Let's see. All right. So we're moving on to sedimentary rock. So sedimentation. The main thing here is you have these particles that are deposited layer after layer after layer, and so the bottommost layers. Let's see if we have any pictures of layers. No, of course we don't. Here, I'll find one. All right, so here's an example, right? If this rock underwent sedimentation, or sedimentary rock, and so the lower layers are older than the layers up towards the top. That's a general rule. All right, so okay, so I just showed you the different layers. So as the sediments accumulated, changes into sedimentary rock, and you have this called lithification. So it's basically turning something into rock. It has two steps. Compaction and cementation. In other words, they're gluing together this material in a layer by layer manner, right? Otherwise, it wouldn't be a nice solid rock, right? So, compaction is when you have material that is just weighing it down, right? Just gravity is compressing this stuff. As you made not you made, but nature has made a sedimentary, or begins to make a sedimentary rock. It'll get crushed, and then how is it cemented? You get basically the release of these pores of water, which are these little regions within the material of dissolved minerals. So there's rocks that have a little bit of water in there. That there's dissolved minerals, and then the minerals, when the water evaporates, this stuff acts like a cement, basically. All right. Let's see. Classification of sedimentary rocks. Okay, so it has to do with the source of the material. There are what are called clastic rocks that transport sediment particles, and then chemical rocks where they were once in solution. All right, we'll do more of that in a